So let's just make a little comparison between acids and bases. So here in general, you should already know this from grade 10 when you took a little section with that you did some acid-base neutralization reactions, and so you know a couple of things. You might have noticed that a lot of the acids, when you write them, they have a hydrogen atom in front of them. When you put them in water, the hydrogens separate from the hydrogens. The hydrogen ion is what makes this solution acidic. So if you take, for example, hydrochloric acid, it will dissociate into hydrogen ions. We call this a cation, and then into chlorine minus, which is a chlorine ion, which is an anion. Same with sulfuric acid. So you have two hydrogen ions and a sulfate ion. So you can see that both of these have hydrogen ions in the solution. Now most bases, if you can see that, dissociates, and when they are written, they have a hydroxide ion at the end. In water, if bases come in contact with water, they separate and form hydroxides. So the hydroxides is what causes the solution to be basic. So if you take a look at sodium hydroxide, you have the sodium cation in solution, and then the anion, which is hydroxide. KOH, potassium hydroxide, same thing, you get hydroxide ions in solution versus your hydrogen ions. So let's just take a look at some overall observations of acids. So it conducts electricity very well. They are sour tasting. If you think about vinegar or lemon juice, they're very reactive, especially with metals. They're corrosive, can burn your skin, so be careful. Acids can be dangerous. Sulfuric acid and nitric acid are especially dangerous when they are released into the environment. So I will also show you how hungry these hydrogen ions are for water. It is extremely dehydrating because it pulls all of the water out of compounds. Now bases, in the if you had to just make qualitative observations, you can also call them alkaline. Will also conduct electricity very well. As opposed to sour tasting, it is bitter tasting, and if you get it on your hands, it feels slippery. They're also dangerous to your skin, especially when it's very strong. Bases are used to clear sinks. So if you ever use drain cleaner, that is a sink that will attack proteins, and a very strong base. So let's take a look at some examples of acid. So here is acetic acid, vinegar. Remember this name, we are going to use a lab where I'm going to call it acetic acid. You need to know that it's vinegar, and this is the formula for acetic acid. And citric acid, oranges and lemons, ascorbic acid, vitamin C, carbonic acid, and carbonated drinks, HCO3, acetylsalicylic acid, which is used as pain medication, and aspirin, and sulfuric acid used in car batteries. Hydrochloric acid is what your stomach makes to digest all of your food. Let's take a look at some everyday examples of bases. You get sodium hydroxide, drain cleaner, potassium hydroxide, soap and cosmetics, sodium bicarbonate in baking soda, and NH3 is ammonia, and then you get a calcium hydroxide, which is lime water. Important to know these formulas and what their common names could be, or where you could find them. So let's take a look at our pH levels. Now pH, you should know, is the factor of hydrogens, but we're going to talk about pH in more detail, but just general knowledge that acids has a pH of 0 to 6.99999, and bases have a range of 7 to 7.000001 to 14. How do we tell if something is acid? We normally use indicators. So a blue litmus paper turns red in a base. Red litmus paper turns blue. Then you can also get phenolphthalein in an acid. It doesn't have any color. As soon as it gets in contact with the base, it will turn pink. Methyl orange is pink in solution of acid and turns yellow in a base. Bromothymol blue turns an acid yellow and stays blue in a base. And that is your comparison chart. Now it's important to go over this chart, understand it. This is a great question, long answer question for your test or your final exam.